Howdy, my name's Rebecca. I'm joined here today by Charlie's, Gabriel, and Robert. And today we're going to be talking about our final semester group project, the Ball and Beam. All documentation about this project will be linked in the following team folder. We will also be posting the YouTube link video of this proposal to the same side once we finish. As a brief overview of what this project looked like, the goal is to essentially balance the ball by using the position of the beam and the angle of the beam.
Based on the configuration of the experiment, the way it balances determines the output voltage due to it acting as a potentiometer with the metal ball and the metal track interacting with one another. Based on this output voltage, it is converted into data through the Arduino, which can later be used as a experimental data for our simulation to model against.
Now, for the plan of execution, we have three components, being the mechanical components, the electrical and the computer components, and the simulation components. So within mechanical, the team will first off need to get a solid metal ball as well as a metal rod where the ball can slide on, while also 3D printing all of the supports for this rod and ball. The students will also need to set up a piston and a motor on one side to shift the ball to where it is needed to be. Then for the electrical and computer components, the students will need to 3D model the supports and the rod using SolidWorks. The motor is also going to be connected to a small circuit that will cause the motor to move up and down, which thus moves the piston to move the rod. The students will also be measuring the voltage across a resistor that is connected to the full system using that Arduino, and the voltage is then altered based on where the ball is moved to on the rod. Now, with the simulation components, the students will be simulating the entire system using MATLAB and Simulink, as well as the team will be making a physical simulation in real life to see if the theoretical model works in real life. And this is the distribution of all of the work that we will be doing throughout this project. It's listed on this slide.
In terms of timeline for the project, we first have the project proposal video here, which is going to show the entire scope of the final project, which is then going to be followed by modeling the system both in Simulink and SolidWorks to obtain our theoretical data. And then we will be modeling the system physically to get experimental data. The expected outcomes of this project will be a complete modeled version of the system created on MATLAB using both Simulink and Simscape libraries, which can then obtain theoretical data, which will be used against the physically modeled experimental data to obtain error. Then the ball and beam can be used as a real-life application, as a makeshift potentiometer, and can be used for variable resistance applications.